Hi, this is Lisa. I'm going to talk to you today about dimensional analysis and conversions. Dimensional analysis is a way to set up a dosage calculation problem that will include all of the data in it and that you can calculate and figure out everything you need to know in one problem. There are a few ways to do dosage calculation questions. There's ratio to proportion and dimensional analysis formula. These ways, you can do them if that's how you do math. Just know that you cannot put all of the steps that you need to put into dimensional analysis. You can put all of your conversions, everything you need to do in one problem. And then you won't have to worry about remembering to convert something from milligrams to milliliters or something like that. The formula and the ratio to proportion will take several steps, and that's why we like for you to learn dimensional analysis. The formula and ratio to proportion will help you in level 1 when you get to the critical care math. In level 2, it's going to be a lot more challenging to put it into formula or ratio to proportion. So if you learn dimensional analysis right away, you'll be fine. There's 4 steps. I will put these steps on Canvas for you. The first step is, what label do you need, or just plain, what do you need? So if you look at the question, it's always going to ask you to convert or do something. So you want to look at what your final conversion is. So if it's milligrams, you want milligrams. If it's liters or anything like that, but you want to know what you need. And that's going to be how you set up your problem. And then you're going to need to know what information is there that you know about what you need. And if you go back to, I think it's the second podcast where I talked about conversions, these are a lot of the things you're going to have to memorize and you'll just have to know, and that's what you put into your dimensional analysis. Number 3, place the remaining information to cancel out all your labels. The goal of dimensional analysis is to get rid of all of the labels except for what you need. And that'll make more sense when I show you the problem. And last is do the math. So if you remember these 4 steps, you'll be able to set up your dimensional analysis without any problems. Okay, so we're going to talk about conversions for just a minute. And if you remember from the first podcast, I told you you're going to have to take the information you know about conversions to solve problems. So example, you're going to have to know that 1 milligram is 1,000 micrograms. When you get your dosage calculation test questions, it's not going to give you this information. You're going to need to know it and plug it into the formula. And I already talked about that next bullet point. It's just going to help you with your advanced dosage calculations. So memorize your conversions from the second podcast is the whole point of this slide. So we're going to start. And if you look here, our problem is we need to take 3.5 grams and convert it into milligrams. So step 1, what do we need to know? We look, and what we know is we have 3.5 grams, and what we're trying to figure out is how many milligrams. And I showed you how to do on the second podcast the moving the decimal points. You can do that, but you can also set up a dimensional analysis just to make sure you're right and get used to doing this. But what we need to know is milligrams. Oh, I forgot my pointer. I have a beautiful pointer here. Milligrams. So what we need to know is milligrams. So we're going to set it up. We're going to say X milligrams. So we're trying to figure out how many milligrams. And then we're going to determine what we know about milligrams and grams. So the whole point of dimensional analysis is whatever you need, you want to have that in the numerator of your problem. So we know that 1,000 milligrams equals 1 gram. So that's number 2. We're going to look for what known quantity do we know. So we know that 1,000 milligrams is equal to 1 gram. We have our milligrams on top, and then we have our grams on the bottom. So now we're going to have to set up a next problem, and we're going to need grams on the top of that. So we're going to go to this page. So we know we have 1,000 milligrams is 1 gram, and I'm going to jump down here. And we need to convert that 3.5 grams to milligrams. So we're going to put 3.5 grams. It's going to cross out the G's, and it's just going to leave us with 1,000 milligrams times 3.5 divided by 1. So again, we've got our milligrams. That's what we're looking for. So if we do the math, we take 1,000 milligrams times 3.5, because our grams are gone, that gives us 3,500 milligrams. So that's dimensional analysis. You're going to figure out what you need, what you know, and what you need to get rid of, basically. Or not get rid of, but the labels you need to get rid of. So we're going to do a weight conversion next. So if we remember, 1 pound equals 2.2 kilograms. And that was on our conversion sheet from podcast number 2. And what we're going to do is just keep that in the back of our mind. We're going to look at our problem. And the patient weighs 190 pounds. And we need to convert the weight to kilograms and round to the nearest tenth. So if you remember our rounding rules, we're going to tell you where to round. So what do we need to know? We know the patient weighs 190 pounds. We want to figure out how many kilograms. So we need to know kilograms. Step 2, we're going to look for what we know about kilograms. So we have X kilograms, and we know that 1 kilogram, because we want to have a kilogram in our top number, is equal to 2.2 pounds. So, sorry, I'm trying to get caught up on my sheet here. So we're going to set up the first part of our problem is 1 kilogram, 2.2 pounds. Now if we look at this bottom number, we need to get rid of that pound. So we're going to take 1.1 kilogram over 2.2 pounds. We're going to multiply it times the 190 pounds that the patient weighs. So if you go back to our problem, the patient weighs 190 pounds. So I'm going to cross off my pounds. So I'm going to get rid of the pounds at the 190 and the pounds at 2.2. And we're going to do the math on the next page. Sorry about that. We have 190, so we'll multiply that times 1, and we're going to divide it by 2.2, and that's going to give us 86.36363664. And our orders tell us to round to the nearest tenth. So what we're going to do is we are going to take that 86, we're going to go to the 10th spot, which is here. We're going to look over at the 100th spot. The 100th spot, the number is greater than 5 or greater. So we're going to, oh, that's wrong. We're going to round up. It's going to be 86.4, not 86.3. I did that wrong. So 86.4 is your correct answer. 86.4 kilograms. Okay, now we're going to convert 2 teaspoons to a milliliter. So what do we need? We need to know how many milliliters. And what do we know? We know that 5 milliliters is equal to 1 teaspoon from our conversions from the second podcast. So we're going to place this into a chart. So we've got X milliliters. We know we want milliliters in the numerator. So we know that 5 milliliters is equal to 1 teaspoon. And we want to figure out how many 2 teaspoons are. So we're going to multiply this times 2. You can have an underline and a 1 underneath if you want to. I don't, but if you want to do that, that's fine. Either way, it's understood there's a 1 there. So we're going to cross out our teaspoons. So with the teaspoons gone, we're left with milliliters, which is what we're looking for. We're going to take 5 times 2, and it equals 10 mils. So 2 teaspoons is 10 mils. So seeing how we do this, we always just look for what we need, look for what we know, and then try to have our conversions. So this one is a patient drank 12 ounces of coffee, and we want to convert that 12 ounces to milliliters. Because when a lot of our containers in healthcare are marked in ounces, and then when we document what the patient consumed, their intake, we want to document it in milliliters. So here, what do we need to know? We need to know milliliters. So we're going to have X milliliters. And what do we know about milliliters? We want to always have milliliters on top of our numerator, so we know 30 milliliters is equal to 1 ounce. So if we're in 1 ounce, you have 30 mils. And we know our patient drank 12 ounces of coffee. So we're going to put 12 ounces over here. We're going to cross through, get rid of our ounces. So that leaves us 30 mils times 12, which is 360 mils. The problems are going to get more complicated as we go along, and you'll be adding more factors. But for now, I just want you focusing on the simple I know this is funny, but it's simple. Setting up your problems. What you need, what you know, what you need to cancel. Okay. And so for our last problem, the patient receives 2,500 milliliters of IV fluids. How many liters did the patient receive? So we have X liters, so we want to figure out how many liters. We set up our first fraction, so we want to have liters in the numerator. So we know 1 liter is 1,000 milliliters. And we know the patient received 2,500 milliliters. And so this is what we're going to put here to cross out our milliliters. Oh, sorry about that. Cross out our milliliters, which leaves us 1 liter times 2,500 divided by 1,000 will give us 2.5 liters. So again, just making sure what you need is set up here, X liters. Have your liter, your matching labels in the numerator. Have what you know about the liter, so we know that 1 liter is 1,000 mils. And how you know how to pick what's in your numerator or in your fraction is you look for what you know and what you want. So we know that 1 liter is 1,000 mils, and then we multiply that, do the math, and we get 2.5 mils. There will be practice problems posted online. There will also be a quiz that you can take multiple times. If you're having problems with dimensional analysis, please see either your level 1 faculty, Beth Bauer in the lab, or myself, I'm Lisa, I'm level 2, but I'll be in the lab in the sim, so don't hesitate to ask. Thank you, and have a good day. And remember, math is fun.